Hello, fellow chemists. In this video, we're going to take a look at some advanced dosage problems. This video is labeled as intermediate because it assumes that you understand the basic concepts of dosage and know how to use dosage to solve for mass of drug and mass of person. If you need to review those topics, I'll put a video tab in the upper right hand corner for you. So let's get into this video. I have two problems here, and these are typically labeled as intermediate level problems because they have some more information in them. They take more steps to solve, and it usually takes the reader a little bit longer to map out the correct pathway to solving the problem. So if these were on an exam in, say, a nursing chemistry course, they would be labeled as intermediate dosage problems. They wouldn't be the hardest. I'll have a video after this on those, but they're definitely not the easiest either. So let's take a look at the problems and get started. For the first problem, it says if a 200-pound patient needs to take a drug 3 times a day for 7 days, and the dosage for the drug is 15 milligrams per kilogram. After 7 days, how many milligrams of the drug will the patient have taken? All right, once you start to get the problems of this level, this is where students start to tell me, I look at the problem and I have no idea where to start. Because now you're getting to problems that are multiple sentences in size. They got 3 to 5 pieces of numerical information in them. And a lot of times they'll just start writing stuff down. And that's the worst thing that you can do. First thing you always need to ask yourself is, what am I being asked to solve for? So it says, how many milligrams of drug? That is the first thing you always look for in a problem. What are you being asked to solve for? So we're being asked to find total milligrams of drug. Okay, and then once you figure that out, now you need to see what information is given to you in the problem. Well, we're told the patient's weight, so we have a 200-pound person. And remember, in dosage problems, it's always important when you're looking at masses to make sure you know, is it the mass of a person or mass of drug. So this is person, so I'll put a little p under there. So you have 200 pounds for the mass of the person. And then we're also given the dosage as 15 milligrams per kilogram. So we'll write that up here. And the 15 milligrams is of drug, and the 1 kilogram is person. Okay, so we want to make sure we have our masses specified, whether it's mass of drug or mass of person. And then we're told that he takes the drug 3 times per day. So that means 3 doses per 1 day. And it says that he's taking the drug for 7 days. So we need to find total milligrams of drug. We know he's taking it for 7 days. He's taking 3 doses per day. We know that the dosage is 15 milligrams per kilogram and he weighs 200 pounds. So where do you start with something like this? I always start by looking at units and canceling out every unit except the unit that I want to have at the end. We want to have total milligrams of drug. Here's your milligrams of drug. This is mass of a person, and this is mass of a person. This is in pounds, this is in kilograms. If we convert his mass from pounds into kilograms, we can have these two masses cancel out, and we'll be left with just mass of drug. And that's how much drug he will take in 1 dose. Then it's telling us that he's taking 3 doses for 7 days. So we can have days and days cancel out, and that will tell us how many doses he's taking. And then we can cancel out doses, and we'll be left with just total amount of drug. So let's kind of chart out the steps that we're going to need to take for this problem. We'll start with pounds of person, and we'll convert to kilograms of person. That'll be the first step. And then we will use the dosage to go from kilograms of person to milligrams of drug. And for that step, we're going to use the dosage. And then once we have milligrams of drug, we need to get to milligrams of total drug. And to do that, we need to find out how many doses he's taking. So this is total doses that we're going to need to use for that step. So this problem is going to be 1, 2, 3 steps long. So let's get started. Now that we have it kind of mapped out what we need to do, we can start with the first step, which is getting the person's mass from pounds into kilograms. So we have 200 pounds. And if you remember, the English to metric conversion for pounds and kilograms is 2.2 pounds for every 1 kilogram. We have pounds and pounds diagonal, so they will cancel out. And when we take 200 times 1 divided by 2.2, we get 90.9 kilograms. Now that is still for the person, that's the person's mass. And that is step 1 complete. Now in step 2, we're going to take the person's mass in kilograms, use the dosage, and convert it to mass of drug in milligrams. Okay, so get the dosage, put kilograms on the bottom because we want it to cancel out, and milligrams on the top because that's what we want to end up with. And the dosage is 15 milligrams of drug for every 1 kilogram of our patient. Kilograms and kilograms cancels out. We'll take 90.9 times 15 divided by 1, and that will give us 1,364 milligrams. And that's 1 dose per 1 dose of our drug. So now we know how many milligrams of drug he gets each time he takes a dose. Now we know that he's been taking this, so that's the second step there. Now we need to find this total doses here to find the total amount of drug. Well, we know that he takes the drug for 7 days, and that he takes 3 doses per day. So we'll put day on the bottom, so it cancels out, and dose on the top. 3 doses per day, so days and days will cancel out. So the total amount of doses that he will take at the end of 7 days is 21 doses. Now all we have to do is find out the total amount of drug. So he has 21 doses. And 1 dose, put it on the bottom so they cancel out, is 1,364 milligrams. Now doses and doses cancels out. And the total amount of drug that he will take at the end of 7 days is 21 times 1,364 divided by 1, which gives us 28,644 milligrams. And I'll put of drug. So 28,644 milligrams is how much drug our patient will take at the end of 7 days if he takes the drug 3 times a day, and the drug has a dosage of 15 milligrams per kilogram, and he weighs 200 pounds. Okay, so that's the first problem, and you can see how that's a little bit more advanced because it brings in taking multiple doses of a drug to figure out the total amount of medication that the patient takes. The second problem brings in a common situation, and that is when you're looking at a liquid medication, you often need to mix in densities with dosages. So this second problem down here has a density associated with it. And let's take a look at it. It says, how many milliliters of drug will a 75-pound patient need to take if the dosage of the drug is 2.5 milligrams per kilogram and the density of the drug is 1.27 milligrams per milliliter? Again, it's not uncommon for students to look at this and say, I have no idea where to start. But what you always want to start with is, what am I being asked to solve for? How many milliliters of drug? So we need to find milliliters of drug. So I'll put that up here on the right hand side. Milliliters of drug. So we want every other unit to cancel out except milliliters of drug. That's what we're looking to solve for. So let's also write up here, well, what other information are we given? We're given that the patient is 75 pounds. Okay, and that's the patient's mass, not the drug mass. We're given that the dosage is 2.5 milligrams per 1 kilogram. And this top number here is drug, and the bottom number here is patient. So it's 1 kilogram of patient for every 2.5 milligrams of drug that they will take. And then we're also given the density. That's the symbol for density there. And that is 1.27 milligrams per milliliter. 1.27 milligrams of drug per 1 milliliter of the drug. All right, now again, what I do is I start trying to see here how to start. I try to cancel out units until I'm left with the one unit that we're being asked to find. Well, what are we being asked to find? Milliliters of drug. So let's see if we can get everything else canceled out. Well, if I convert this person's mass from pounds into kilograms, I can have the mass of the person and mass of the person cancel out. Then I have mass of drug. But we don't want our drug as a mass, we want our drug as a volume. Well, we'll use the density to have the mass of drug cancel out with mass of drug, and the only unit that will be left then is volume of drug. So let's see what steps that's going to be. We're going to start with the person's weight in pounds, and that's a person's weight, not a drug weight. And we're going to convert that into kilograms. That's still going to be the person's weight, but it's going to be in kilograms now. And then we'll use the dosage to get to milligrams of drug. Okay. That'll be the dosage step. And then once we get to milligrams of drug, then we'll use the density to get to milliliters of drug. So in this step, we'll use the density. Okay, so this problem here will actually be 1, 2, and 3 steps as well. So let's, now again that we have it kind of mapped out, that's the hardest part, is getting it mapped out. Now that it's mapped out, we can just kind of go about doing each of the steps. And again, this is the number one mistake that I have students make. They just start writing stuff down without knowing actually having a plan of how to solve the problem. So we're going to start off with the person's mass in pounds, 75 pounds. And we're going to convert that into kilograms so that we can use our dosage. Put pounds on the bottom so it cancels out, kilograms on the top. 2.2 pounds for every 1 kilogram. Pounds and pounds cancel. And a 75-pound person, if you multiply by 1 and divide by 2.2, a 75-pound person weighs 34.1 kilograms. And again, this is still mass of person. Okay, so we know that we're not talking about mass of drug here. So that's the first step that we completed. Now in the second step, we need to use the dosage to convert from mass of person in kilograms to mass of drug in milligrams. So again, we'll put kilograms on the bottom so it cancels out. Milligrams on the top. And the dosage is 2.5 milligrams for every 1 kilogram. Kilograms and kilograms will cancel out. And a 31.1 kilogram person times 2.5 divided by 1 will take 85.3 milligrams of drug. Now we're into drug. This is the mass of the drug. And so that's our second step done. Now the third step is we need to use the density of the drug to convert from mass of drug to volume of drug. So we have 85.3 milligrams of drug. Put milligrams on the bottom so it cancels out. Milliliters on the top because that's what we want to end up with. And it's 1.27 milligrams per every 1 milliliter based on its density. Milligrams and milligrams cancel out. And 85.3 times 1 and divided by 1.27 gives us 67.2 milliliters of drug. And that is what we're being asked to find in this problem, the volume of the drug. So that's a problem, a dosage problem, that because you're working with a liquid drug, it requires the density of that drug to convert from milligrams of drug to milliliters of drug. All right, that's it for this lesson. I hope you learned something. If you did, make sure you subscribe and hit the like button, and I'll see you in the next video.